Alright, this is chapter 1.6, problem 4. It says use the linear regression feature on a graphing calculator to find an equation of the line of best fit for the data in problem 3a. Okay, estimate the height of a person whose femur is 35 centimeters long. So, basically what we're going to do is we're going to put all this data into L1 and L2. So go to Stat, Edit. So we're going to hit the Stat button, then we're going to hit the Edit button. I'm going to put everything in. I'm going to pause real quick. I'm going to do that real fast on my computer, on my calculator. Okay, I got all mine in my stat function now. Pause if you need to do if you're still doing it. But just remember, when you put them in, make sure you can put them in 40 down to 45 and then hit 70 down to 182. But just make sure that each one of these is lined up with the appropriate data point. All right, you don't want to mess that up. You don't want to do like 37 right next to 151 or something silly like that. Okay, so once you get everything in, we're going to hit second quit to get out of there, and then we're going to hit Stat, Stat, Calculate, C-A-L-C. It's going to be Lin Reg. That's what we're going to hit. That's the section we're going to pick. Okay? So let me do that real quick on my calculator. Alright, so you should have gotten an A value, a B value, and an R value. If you did not get an R value, you need to go up to Mode and scroll down to Stat Diagnostics. And it needs to be on. Okay, if you did not get an R value, so I'll put over here no R. Go to Mode, Stat Diagnostics, and on. Okay, and go ahead and pause the video if you got to do that. But for me, the A value is 2.60. The B value is 64.996. So I'm going to scroll that up to 65. Because that rounds to 9, it rounds to 9, it rounds to 4 to 5, so the B value is 65, and the R value is 0.99. Okay, so remember, that is practically positive 1. So this is a very strong positive correlation. Okay? Alright? This is a very strong positive correlation. So strong positive correlation. Which probably means that it really is a linear function. If we got a really weak one, we would probably say, hey, maybe try a quadratic one, an exponential one, something else. But we got 0.9, so let's go with the linear model. Sounds good to me. So, for this one, y equals 2.60x plus 65, which is actually pretty close to the equation we got. Alright, because 14 over, 40 divided by 7? 40 divided by 17, that was the last problem, is 2.35. That was our slope. And we got a B value of like 74 or something like that, which is not bad in the grand scheme of things. Alright, so estimate the height of a femur that's 35 centimeters long. So, y, wrong button, y equals 2.6, I can drop the 0 at this point, times 35 plus 65. Alright, and let's crunch that real quick. 2.6 times 35 plus 65 equals 156 equals 156 centimeters tall. So, let's capitalize the first letter of a sentence. A 35 centimeter tall person is about 156 centimeters. I totally screwed that up. It's not a 35 centimeter tall. It's someone with a 35 centimeter femur is about 156 centimeters tall. Okay, so that answers the first question. And examine the correlation coefficient. We've already done that. The correlation coefficient is 0.99. So, and like we said, that is very strong positive correlation. It's about as strong as you can get. All right? And there you go. Happy hunting.